Imagine this. All of human knowledge disappears overnight. Books are gone. The internet is gone. Every scientific theory, gone. Now, you're allowed to save just one sentence to help humanity rebuild science from scratch. What sentence would you choose? One physicist argued that the best possible sentence would be this: everything is made of atoms. Today, we're going to unpack why that single idea is so powerful, how it explains the behavior of matter, and why understanding atoms is the foundation of all physics. Let's start with the idea itself. The atomic idea says that everything around us, air, water, metal, stars, even you, is made of unimaginably tiny particles called atoms. But atoms are not little static dots. They are always moving. They vibrate, collide, stick together, break apart, and rearrange themselves. And from that motion comes temperature, pressure, chemistry, and life itself. Think of matter like a giant crowd of microscopic balls. You don't see the individual people in a stadium from far away. You just see the crowd. In the same way, we don't see atoms directly, but their collective behavior creates everything we experience. This single idea explains why solids are rigid, why liquids flow, why gases expand, why heating something changes its shape. And we don't need complicated math to see how. The physicist Richard Feynman summarized this idea beautifully when he said, "Everything is made of atoms, little particles that move around in perpetual motion. That's it. No equations, no jargon." Now, let's explain what that actually means. Atoms behave differently depending on how much energy they have. Solids. In a solid, atoms are packed closely together. They can't move freely, but they vibrate in place. That's why solids keep their shape. Liquids. In a liquid, atoms still attract each other, but they can slide past one another. That's why liquids flow, but don't instantly spread out. Gases. In a gas, atoms move fast and mostly ignore each other. They bounce off walls, off each other, and fill whatever space they're in. That's why air expands to fill a room. Now here's the key idea. Temperature is just a measure of atomic motion. Hotter means atoms move faster. Colder means they move slower. Nothing mystical, just motion. Let's apply this idea to something concrete. Why does air pressure increase when temperature increases? Imagine a sealed box filled with air. Inside the box, atoms are constantly hitting the walls. Each collision delivers a tiny push. Pressure is just the combined effect of trillions of these collisions. Now heat the box. What happens? The atoms move faster, they hit the walls more often, and they hit harder. More collisions plus stronger collisions equals higher pressure. That's it. No new forces appear. Nothing mysterious happens. The entire effect comes from faster moving atoms. This same logic explains why tires expand on hot days, why balloons shrink in the cold, why engines and refrigerators work. One idea, many consequences. Let's clear up a few common misunderstandings. Misconception 1. Atoms are tiny solid balls. Not really. They're more like fuzzy probability clouds. Misconception 2. Atoms are mostly empty, so matter isn't real. Atomic forces are very real. Empty doesn't mean nothing. Misconception 3. Atoms only matter in chemistry. Atomic motion explains heat, sound, pressure, and even stars. Understanding atoms isn't optional. It's fundamental. Here's why the atomic idea is so powerful. If you understand atoms, you can explain why ice floats, why metals expand when heated, why perfumes spread through a room, why the sun shines. And every deeper theory in physics, thermodynamics, quantum mechanics, and chemistry builds on this foundation. That's why this idea is such a perfect place to start. In the next video, we'll take this idea further and ask, if atoms are always moving, why does time only move forward? If this explanation helped you, like the video and subscribe. And here's a question to think about. If atoms never stop moving, is absolute stillness even possible?